Let's talk about continuous delivery and how building quality into our deployment pipeline makes life easier for everyone. Continuous delivery is the application of a number of techniques that allow teams to deliver value to customers faster and more safely. At first, going faster and more safely appear to be at odds. However, the introduction of automation creates a quick feedback loop, which can reduce risk and at the same time increase the flow of value. In short, the objectives of continuous delivery are to have short feedback loops, faster and safer delivery. We can track the origins of continuous delivery back to the Agile Manifesto. The first of the 12 principles of the Agile Manifesto reads, "Our highest priority is to satisfy the customer through early and continuous delivery of valuable software." Also, continuous delivery is one of the key capabilities of a DevOps approach to delivery. Continuous delivery introduces the concept of a deployment pipeline, sometimes just shortened to a pipeline. The pipeline defines and automates the steps to deliver a solution. A solution contains everything needed to define and validate the software. The majority of the solution is typically code, but it also contains a definition of the underlying database, any static data, and documents. As we'll see shortly, the solution also contains automated test cases to validate correct operation of the software and can even contain a definition of how the underlying infrastructure that the software runs on should be set up and configured. Let's walk through some of the steps of an example pipeline. The start point for a pipeline will be a change to the solution. Typically, we think of this change as a code change. However, there are many trigger points for a change in the solution. More on those later. Once a change is ready, someone commits the change, and this commit starts the pipeline. The commit will trigger the automatic process to build a new version of the solution. Typically, this will result in a number of outputs or artifacts that constitute the solution. The next step is to execute the unit tests against the newly built solution. Unit tests are automated checks that validate the smallest testable part of the software. The unit of code typically has a few inputs and outputs, and is tested through code executed against the unit of code. Unit tests should not be confused with testing through a user interface, e.g. a page or a screen. This is very much low-level testing. The next step is to take the artifacts from the build step and install or deploy them to an integration environment. This tests the successful deployment of the solution. Next is the acceptance test step. This is where integration and regression testing are automatically executed against the solution in the integration environment. The acceptance tests will create or use synthetic test data generated in this step. The acceptance tests should prove that the solution works as intended. Finally, the solution is automatically deployed to the production environment for our customers to use. Importantly, each stage has a pass or fail, giving immediate feedback to the person making the change that there is a problem with the change to the solution. Typically, we would expect the feedback from the automated pipeline to be within 10 to 20 minutes. This can require dedication to maintain the speed of the automation. Now let me talk you through how a pipeline might look and some of the technologies that sit behind the pipeline steps. It's important to note that a pipeline should be started many times a day. The focus should be on small and incremental delivery of value. The commit step will require submitting a change to source control system, like Git or TFS. The version control system holds a record of each change, when it was made, and the person who made the change. The change could be a code change, a configuration change, or even a change to the tests. This commit triggers the start of the pipeline. The build step will use a continuous integration server to get from source control the latest version of the solution. The solution will be built on the continuous integration server. If the build is successful, a number of artifacts will be dropped into the build folder. Only a successful build will move the pipeline to the next step. Failure of the build will give feedback to the person making the change. The unit test step will execute the unit tests in the solution to determine that the low-level testing successfully completes. The output from the step is a number of statistics about the tests. Number of tests passed, number of tests failed, as well as the lines and percentage of code that the tests check. This is known as the code coverage. On successful completion of the unit test, the pipeline will move to the next step. Failure of the unit test will halt the pipeline and provide feedback on the test failures. The deployment to integration step takes the artifacts from the build process and installs them on the target environment. An environment could be a collection of servers and other infrastructure needed to run the software. The environment should be a close approximation to the target production environment to give accurate deployment feedback. Dependent on the target environment as to the deployment technology used, this could be inbuilt TFS features or PowerShell. Once the solution successfully installs, we move to the next step. Failure to install will halt the pipeline and provide feedback on the install issues. Once deployed successfully, the acceptance tests are executed against the deployed solution. Typically, these tests are defined in the Gherkin syntax, given, when, then, and stored in source control alongside the solution. Gherkin tests are living documentation of how the solution should work. Technologies that might be used to connect the Gherkin tests to the solution are Selenium, White, and SpecFlow. If all tests complete successfully, we move to the next stage in the pipeline. Again, failure of the acceptance tests will halt the pipeline and provide the feedback on the test failures. The deployment to next environment step runs the deployment process again, this time with different variables for the target environment. If we have a stage of manual exploratory or user testing, the deployment could be to a test environment. The pipeline allows for manual approval gates to facilitate pulling or pushing through stages of the pipeline. In teams where the adoption of continuous delivery is advanced, this step will deploy the solution to the production environment. A more advanced implementation of continuous delivery will introduce the concept of infrastructure as code. This is where we add to the deployment steps the automatic provision or creation of the infrastructure that hosts the solution. The definition and creation of the infrastructure is held in source control alongside the solution code, configuration and tests, so that a change to the infrastructure configuration is treated as a trigger for the pipeline to start. This concept can be used on virtualized on-prem environments as well as cloud-based solutions. Technologies like PowerShell and ARM templates can be used to deliver infrastructure as code. What I hope we have demonstrated is that continuous delivery can introduce increased speed of delivery through automating the steps of a delivery pipeline. The repeatability and frequency of execution of the pipeline reduces the build and deployment risks. The source control system becomes the record of a complete solution, allowing us to reduce the risks of availability of specialist knowledge and manual intervention. In addition, the automated testing steps further enhance the safety of the change. Ultimately, the team gain quicker feedback on an unintended impact of a change, meaning the team have more time to focus on delivering great functionality and improving the software, whilst the customer gets new functionality into production very frequently with confidence that we're not breaking anything.